In the previous video, we had an overview regarding the use callback hook. Similar to use callback, we have another kind of hook, and that is useMemo hook. Let's now take a look at its usage. The useMemo is used to optimize performance by memoizing expensive calculations or computations. It helps prevent unnecessary recalculations by remembering the result of a function when its dependencies haven't changed. It takes two arguments, a function that returns the computed value and a dependency array. The function only re-executes when one of the dependencies changes. Otherwise, the memoized result is used. And this is particularly useful for optimizing large computations or when rendering components that are dependent on intensive or complex calculations, as it avoids recalculating the same value on every render. It might be a little difficult to understand all this in the first go, but let's take a look at an example. I have already created a component with the name useMemo.js. Let's create two state variables, const counter1, set counter1, whose initial value should be set to useState 0. Similarly, we have another variable, const counter2, set counter2. For whom the initial value is once again 0. Alright. Now we are going to create two functions that will be responsible for incrementing the values. So I'm going to create increment 1 two functions we are creating, set counter 1, and we need counter 1 plus 1. Also we have one more function, const increment 2, set counter 2 as counter 2 plus 1. Let's create two buttons. The first button that will increment the first counter, and we need on click, we are going to call increment 1, and it will render the count 1 variable, that is counter 1 variable. Also, we are going to have another button for the second counter, counter 2. Alright, so we need to call the second function, that is increment 2. Let's render our component in app.js, and we are going to check the functionality, useMemo, that's the name of the component. So it's imported automatically. Let's take a look at the browser. We are having two buttons and they work pretty well as expected. Now let's add a feature where we are going to check whether the incremented value in the first button, that is counter 1, the value is divisible by 2 or not. So I'm going to create a function for the same, is even. Since we are using it for the first button, so we have to use counter 1 variable. We will check if this counter 1 is divisible by 2 or not. So if it's divisible, the remainder should be 0. And we are going to render the result in a span tag right after this button. Inside the JSX, just use this isEven function. If this returns an even value, it should print even. If this returns an odd value, it should print odd. Let's check the functionality on the browser. By default, it's even, 0, 1 odd, 2 even, and so on. So our second button is also functioning as usual. Till now, everything works well in this example. But in real world applications, there may be situations where your function is required to be an expensive function. It means that some expensive calculation or some complex calculation is required to be done. So we are now going to introduce some complexity, some expensiveness in this function so that our function becomes slower. So once the slowness is introduced in this function, we are now going to again check the functionality. For introducing this expensiveness, let's create a variable first, I equals to 0. And let's create a loop wherein our I should be less than, let's say I'm writing these many zeros. So you can imagine that how long this loop is going to be. So let's get back to the browser and check the result. So let's click on the first button. So you see that a slowness has been introduced. So in case if you have written a very large value, in that case your browser might even crash. So at this point, as you are able to see that it's not, I clicked on the button and it's not rendering the value. So I can do one thing. Let me exit this page for now. And I can re-render. Let's click on the button. So you can see that it is rendering the odd text, but it is a little slower. I click again. It will take a little time, or 1 second maybe, to print the result. Let's check once again. I clicked again. So you can see that our UI is taking a little longer to update because of that slowness that we introduced, the expensiveness that we introduced. Okay, this is quite justified. But let's take a look at the second button. When we click on the second button, so did you see that once again I clicked? So why the second button is taking a little longer? That we are now required to understand and resolve this issue. Let's first understand that why this is happening. It's happening because when you click on any of the buttons, your function is re-rendered every time. Since it is re-rendered, it will take time for the UI to update. You can optimize this by using the useMemo hook. Using useMemo hook is pretty much like useCallback hook. All you have to do is just introduce useMemo. Also, you will be required to import useMemo. Now, useMemo accepts two parameters. One will be the callback function, and the second one is an array of dependencies. So you can pass the dependency. So the dependency that we need to pass is counter1, so that we can tell React, so that we can tell our component that this is the only variable when you are required to become slow. So when we pass counter1, it would get slow only for the first button, for which we are actually using this expensive function, this expensive calculation. While for the second one, there should not be any kind of delay in the UI update. So let's make a change here, since now this is even is now a variable. So let's remove this. So let's take a look on the browser. Let's test the functionality. I click on the first button. It takes time. Once again, click. It takes time, which is totally fine. Let's click on the second button. So great, it's working nicely. A while back we discussed that whenever we are clicking on any of the buttons, the isEven function is re-rendered every time, which is forcing it to recalculate the value. So what happened here is, when you are clicking on the first button, it recalculates the value. But when we are clicking on the second button, a cached value is being passed to counter1, due to which it does not re-render or does not make delay in the UI update. In other words, it does not recalculate the isEven function, hence making your example an optimized one. Now there might be a little confusion regarding the difference between useMemo and useCallback, since both are used for the memoization or performance optimization. So what's the difference? The difference is that useMemo returns a memoized value, a cached value, while useCallback returns a cached function. So hope now you are aware regarding the performance optimization hooks in ReactJS. In the upcoming video, we are going to cover the useReducer hook. So till that time, stay tuned.